All right, this is a quick video to finish up Exploration 1.2. We did sort of the first half of it in class. We're just going to go through the rest of it here. So we did kind of a long problem talking about McDonald's and its massive profits. Here's a different topic, going kind of the other way. Probabilities, the chance that something occurs, can be, there's two pretty typical ways to express those as a percentage. So in a regular old deck of cards with the four different suits, there, if you just pick a card out at random, there is a 25% chance that that card will be a spade. Another way of saying that, a 1 in 4 chance of picking a spade. If you pick 4 random cards on average, you'd expect one of them to be a spade. Okay, well, stated on its website, the Michigan Lotto system, it has this thing called Lotto 47, where you pick a bunch of numbers, and if you match all the numbers, you win the jackpot. But this is the probability of winning the jackpot: 1 in 10,700 some thousand. All right, like it says, everybody kind of gets that you're not very likely to win the lottery. Uh, but how unlikely is that? So first off, we could compute this as a percentage or as a decimal. So 25% is 0.25. Uh, what if we compute that as a decimal? Now that would mean doing this computation right here. 1 divided by this giant number. All right, here's my old TI-85. 1 divided by 0.737.573. And if I can get this to there, that's pretty good. All right, so mine, we got to fix it a little bit. You can see this comment. If you end up with something that looks like this, it means writing out the decimal number means writing this out, but we got to move the decimal point 8 spots to the left. So 1 spot would be over the 9, and then we'd have to put in 7 zeros. So, there we go. Point 1, 2, 3, 4, 5, 6, 7. Nope, that should be a 0, not a 7. And then 9, 3, 1, 3. If we round it, it would be a 1, something like that. All right. If you want that as a percentage, you would move this over 2 spots and say that percent chance. Either way, it's a pretty small number. But the next question here, well, is it very large or very small? It's definitely not very large. It is a very small number, the probability that you win the lotto. But again, how small is it? So do you understand how small that number is? Kinda, not quite. Okay, like how unlikely is it that we win the lottery? Well, let's explore that a little bit. So another way to deal with probabilities and statements of odds and things, to phrase it a little different, it would be this: that if you played the lottery this many times, on average, you would expect to win once. All right? Okay, that many times. Well, this is how this lotto works. Apparently, there are drawings held 4 times a week. Powerball and Mega Millions are the ones that get the most publicity with the hugest jackpots, and I think they are twice a week. But this is 4 times a week, twice on Wednesday and twice on Saturday. So how long would it take to play this that many times? Okay, well, 4 times a week. How long is it going to take to do this many times? Well, okay, 10, 7, 3, 7, 5, 7, 3. We'll divide by 4. So 4 plays per week would give us 7, 5, 7, 3 divided by 4. All right, I got 2, 6, 8, 4, 3, 9, 3, and there's a little decimal 0.25, and I'm just going to leave that off. Oops. So that many, and the unit is important here, it would take you that many weeks to play this many times. All right, well, how many days is that? We're going to keep making some conversions here. How many days is that? Okay, multiply by 7 times 7. It's a whole lot. 18790,752. I should say this number times 7 is this. So if we put commas in, that's how many days that is. Oh, I put my commas in wrong last time. That should be a comma. That should be a comma. That's better. Yes. Okay. How many years is that many days? All right, 365 in a year. So we'll just take that and divide by 365. I'm just going to do that on my calculator. Divided by 365. And ignoring the decimal again, 51481. So now this number divided by 365 is 51481 years. All right, one more conversion to try and get a handle on how small this number is, how unlikely it is that you're going to win this lotto. Average life expectancy for someone in the United States was recently computed to be 77 years. So if a single lifetime is 77 years, how many lifetimes is this? So we're going to take 51481 and divide it by 77. And that will be, so divided by 77, 668. I'll just, again, ignore the decimal. 668 lifetimes. So, what are we saying here? We did all these conversions and we turned it into this. So the probability of winning lotto is small. How small? Well, basically this. If you played every drawing of Lotto 47 for 668 lifetimes, on average, you would win once. So that is from birth to death on average, playing 4 times a week for 668 lifetimes, you'd expect to win once. It's even then not a guarantee that you would actually win once. All right, there it is. That's how small the probability is. And even when we turned it, I mean, that's a big number, this 10 million number. And we did some conversions, and what we came up with down here is an analogy, something that relates this new number, this very small decimal number that we got here, or these very unlikely odds, and compared it to something that is maybe a little more understandable. All right, down to 668 lifetimes. All right, we got just one more page. We're going to look at a couple things and actually go back to McDonald's to talk about the rest of it. Okay. So earlier in this exploration, we saw this was McDonald's profit in 2024, $14.71 billion. It turns out in 2023, it was really close, just a smidge less, 14.69 billion. So what would their total profits be for 2 years? And the point that we're making here in the role of units when we're working is that it's a lot easier to make your unit in billions of dollars rather than just dollars. If you wanted the unit to just be dollars, you would have to write out that whole entire number with all of its digits. And likewise, for this number for 2023, you'd have to write out 14,690, and then the appropriate number of zeros after that. But what's much simpler is to actually use a unit that isn't just dollars, it's billions of dollars. So this number 14.69 is counting billions already. So basically, we just need to do 14.71 plus 14.69, and those are manageable sized numbers. We just got to add them up, and it's 29.4, I believe. Here it comes. 29.4. 29.4. And then in terms of the unit, well, we'll use the dollar sign $4, but then we'll write billion after that. All right. And, well, the next question is getting at what we were just talking about. Is it easier in units of dollars or billions of dollars? Well, clearly it's in the unit of billions of dollars. The actual digits involved make small numbers, 14.7, 14.69. Those are easy numbers as opposed to writing out 11-digit number plus another 11-digit number and keeping your answer as another 11-digit number. Okay, the last thing, we're just going to look at an Excel file. This one is available on Canvas if you wanted to open it up yourself. But if we were doing this in class, you would just look at it with me on the screen, and we'll just answer a few questions about it. So this is our first look at a spreadsheet. All right, so this is the Excel file. And this contains some older data about the McDonald's Corporation. This is not profit, this is revenue. So amount of money taken in. One thing with Excel files, this looks kind of small and there's all kinds of extra room. The little zoom bar is down here, so you can blow this guy up and make it easier to read, like so. So this, what we have here, well, we've got obviously 4 years, 2013 through 2016, and we have different markets. All right, so the McDonald's restaurants that are in the United States, what kind of money was taken in by them. And then we have 3 different international markets. So all the other McDonald's stores sorted into, well, leading internationals, which I take to mean the more substantial markets, the more historically solid ones, new international markets, locations that are growing in terms of McDonald's restaurants and whatnot, or maybe everything, and then other ones that don't fit those 2 categories. All right, so in each cell, that's what all these little blocks are called, there's a number, and if you follow, we've got the letters across the top and numbers across the side, and if you take a cell, every cell has a name with a letter and a number. So the very first question is, what is the number in cell D5? All right, so column D right here, row 5 right there, and those guys intersect right here. I'm just going to turn him yellow. There he is. All right, so the number is 6.17, and I'm just going to jot that down, 6.17. All right, what does it mean? Well, this is in the row for the year 2015, and it is in the column for the new international markets. So what this is telling us, all right, 6.17, this is the revenue from, that was the column of new I'm just going to do this, international markets for, and that was the row 5 was the year 2015. All right, so that's what that cell tells you. Just that one guy right there. Okay. Back to there we go. All right. Question B is asking, what do the row totals tell you? So each row, we have this number over here. And this is the total for this whole entire row. we'll talk about this more later, but I'll just point out, if you click on this cell, the number is 28.11. But underlying that is this guy right here, which is the formula that determines what number is in this cell. And this is the formula for adding up a range of values. So I just want to point that out now, and we'll talk later about making formulas and that kind of thing. All right, so what does each row total tell you? So what does 27.44 stand for? Well, when you add up those four numbers to get this total, what are we generating? Well, it's a total. It's in particular has to do with the year 2014. And this would be taking all of the different revenues or all of the different market segments and adding them all up. So this would be telling us this total is all the revenue for McDonald's. These individual numbers are just the revenue split into these different segments, but all of the revenue for 2014. So every row total is telling us the total revenue for each year. Meanwhile, our columns, so these totals along the bottom, these sorts of guys here, what are they telling you? Well, we're adding up down each column. So each column corresponds to one of the segments, so it would be the total of the revenue in each segment specifically for this range of years. All right, so saying that, we are getting the total revenue in each segment. Well, for all the years that are shown, which is specifically for the years 2013 to 2016. And there you are. Okay. That's it. That's all. Yeah, that's the end of 1. There's one more question on the next page. We're just going to skip over that. But that'll do it then for 1.2.